So we're doing this little review for Chapter 4 right here. Now again, like I said earlier, we haven't taken a test on Chapter 4 yet, all right, but it will be included on the midterm. And we will have a regular Chapter 4 test after all this midterm stuff's over. Okay, we'll take a couple days to review a little bit more on Chapter 4, the chapter that we just finished, and we'll take a regular test on it not too long after the midterms are over, all right? Probably like the middle of that following week after the midterms. All right, so here's a problem that you might see on this Chapter 4 test or something very similar to it. And this is what they ask you to do. They ask you to classify each triangle by its angles and by its sides. You remember doing that? This is kind of recent stuff, right? Because we just finished Chapter 4, so a lot of this is pretty recent. Triangle ABD and triangle ABC. I'll just write these down here. Oops, I'll put the triangle symbol in front of it. And 3 is triangle BDC. All right. And we have to classify it by its angles and by its sides. Now, I'm going to give you a lot of stuff as far as like formulas. Remember we talked about that. I'll give you the distance formula. I'll give you the midpoint formula. And, I'll give you a lot of that kind of stuff. But on something like this, I really feel that you need to memorize what these words are. Okay, I'm not going to give you like every single vocab word that you're ever going to have to learn in here. So there are some things that you are going to have to remember and you're going to have to know. So if I say classified by its, let's do it by its angles first. I'll just put a 1 and a 2. Classify it by its angles. So the first thing we write is what it is by its angles, and then we're going to talk about what it is, what it's named by the sides. So let's look at triangle ABD. Let's find out where triangle ABD is first. Here's A, here's B, here's D. So it's this triangle right here. And we got to say what it is by its angles. What kind of triangle is this triangle if we describe it by its angles? Okay, you could say equiangular. Very good. Equiangular. Now, it's equiangular not because they told me all the angles are equal. How did I know it's equiangular? Because I don't have really any of these angles in here marked. How do I know that all the angles are equal to each other? Because all the sides are equal. That's right. Because we learned something that if all the sides are equal, then all the angles are going to be equal to each other as well. Okay, does that make sense? All right, so we could say equiangular. There's actually another one that we could use if we wanted to. You don't have to use them both, but there is another one. What is it? It's acute. Well, it's isosceles from its sides. Okay, I'm just talking about its angles right now. So yeah, it's an acute angle, or it's an acute triangle, because all three angles, if they're all equal to each other, are all 60 degrees, and that means they're also, what was the word? Acute. They're all acute angles, okay? So if you wanted to, you could say, I'll put an or right here. You don't have to have both of those, but you could have either one of them. You could say equiangular, you'd be okay. You could say acute, and you would be okay. Make sense? All right. And let's now talk about it by its sides. I've got this triangle right here. All three sides are equal to each other, so what can we call it by its sides? Well, we said something already. All three sides are equal. If all three angles are equal, it's equiangular. If all three sides are equal, it's what? Equilateral, right. The word lateral means side. All right, so we could call it equilateral. Now, this is another one where you could have two words for it. Somebody said it earlier. You could call it isosceles as well. Okay, you could call this isosceles. So I'll put another or right here, and isosceles. Does that make sense? Now, you don't have to have all four of these things. You could pick equiangular or acute. It doesn't matter. If you just wanted to pick one of them, just pick one of them, okay? And then you could just pick one of these. But you got to pick one from the angles and one from the sides. So if you wanted to call it equilateral, that would be okay. All right? If you wanted to call it acute and isosceles, that would be okay. If you wanted to call it equiangular and isosceles, that would be okay. You get the idea, right? Okay. Let's take a look at triangle ABC. Now, not all these can you have like two different words that describe the triangles, but this one you could. Let's look at triangle ABC. Let's find an ABC. And a lot of people miss this. And you might have missed it maybe because you just didn't see it. Maybe the square was... Actually, you didn't take a test on this yet, did you? So I'm thinking about my... I must be thinking about my honors class then. You took a quiz on it? Did you have something that looked like this? Yeah, I think it might have been exactly this, right? Yep. Yeah, I think you did. You took how many quizzes have we had on Chapter 4? I think 2. We've only had one quiz on Chapter 4? Okay. Yeah, we'll probably have to have another quiz before we take the test as well. All right, so anyway, look at this. Look at triangle ABC. ABC, right here. Let's name it by its angles, first of all. What kind of angle is in that big triangle ABC? It's a right angle right there. So what kind of a triangle is it? It's a right triangle. All right, so it's a right triangle. So that's by its angles. So we look at the angles, and it's a right triangle. Everybody see that? Now, it does have two acute angles, but we don't call it an acute triangle, do we? We only call it an acute triangle when what? No, acute. When all, not sides, all angles, right. When all the angles are acute, we call it an acute triangle. Okay, if it has one right angle, even though these two are acute, if it just has one right angle, we call it a right triangle. Everybody got that? What about the sides? Look at triangle ABC. It's that whole big triangle right here. This side has one tick mark. This part of this side has two tick marks. This doesn't have any tick marks at all. And this side right here has got one and it's got one. So are any of the sides equal to each other at all? Of the big triangle. Yeah, but this right here is not part of the big triangle. I'm talking just this big triangle. It's got three sides. It's got AB, right? Is AB equal to this side down here? Obviously not, because that has one, that's got one. This is actually twice as big as this, isn't it? What about this third side? Is this third side equal to this side or equal to this side? No, we don't know. I mean, nothing on here says that it's equal. All right, so what do we call it then if none of the sides are equal to each other? Scalene, right. We don't use that word very often, but that's one place where it's used. Destiny? Take a pass. So you've got a right triangle and you've got a scalene triangle. All right? There's nothing else you could call those. There's no options. On here you had a couple options for both of them. There's no other options on this. Okay, it has to be right and has to be scalene, nothing else. Let's look at BDC. Here's B, here's D, here's C. So look at this one right here. What about the angles? Look at the angles on this triangle right here. What do you see? What's one big old angle? It's an obtuse angle, isn't it? You see that? It's got one big obtuse angle, so what kind of a triangle do we call it? An obtuse triangle. Alright, it's an obtuse triangle. Everybody got that? Now let's talk about the sides. What about the sides of this angle BDC, or triangle BDC? Look at this triangle right here. I keep writing around. Yeah, it's isosceles. How do you know that? Well, because you've got one tick mark here and you've got one tick mark here. That means these two sides are equal to each other, correct? So if these two sides are equal to each other, we call it isosceles. And you can't call it anything else. That's it. That's the only thing you can name it. We go to this? You got to know those words, though, okay? I'm telling you right now, I'm not going to give you a list of these words. You have to know the word equiangular, acute, equilateral, isosceles, obtuse, scalene, right? You got to know those words and what they mean. So I'm not going to put that on a list for you. You have to know those words. Everybody understand that? All right. Let's try another one from chapter 4. This is another one that was on the quiz. I think it's exactly the problem from the quiz, to tell you the truth. So let's do this one. Triangle FGH is equilateral. Do you remember this from the quiz? Well, you probably don't know it yet until you start seeing it a little bit more. And they tell you that FG is equal to x plus 5. They tell you that GH is equal to 3x minus 9. And FH is 2x minus 2. And what do they ask you to solve for? They ask you to find x and also to find the measure of each side. Measure of each side. Now, you don't really have to draw this thing out. What do they tell you about this triangle? They tell you it's what? And what does that mean to be equilateral? All the sides are equal. And look what they give you. What is this FG? It's one of the sides, isn't it? What is this GH? That's one of the sides. And what is FH? That's the other side. So these are your three sides, aren't they, of your triangle. And it says it's equilateral. So what do you think you're going to do? Okay, set all three of them equal? Just two of them, right? Just two of them. And it doesn't matter which two. Right? They're all the same, aren't they? They're all equal to each other. So you just pick two of them. I remember on the quiz, I can't remember who did it, but I do remember one or at least once I saw somebody put all three of these things equal to each other and then they tried to solve for x. You can't really do that putting all three equal to each other. Okay, you just set two of them equal to each other, and it doesn't matter which two. All right, it doesn't matter because all three are exactly the same. Everybody understand that? So which two would you like to set equal to each other? Probably the easiest. What do you think the easiest ones? The x plus 5 and... yeah, probably the 2x minus 2. I'd probably do that. But it doesn't matter. You can set any of these sides equal to each other. All right, but it's probably easier to do this. So I'm going to put the 2x minus 2 first equals x plus 5. And why can I do that? Because the triangle is equilateral, which means all the sides are equal to each other. So these two are equal to each other. Let's do the math. Subtract x from both sides and add a 2 to both sides. So that cancels, that cancels. 2x minus 1x is x. All right, equals 5 plus 2 is 7. So x is equal to 7. Do we stop right there? Is that our final answer? Some people did on the quiz. They stopped right there. They did it right. They set it up right, and they got x equals 7. They went on to the next problem. But I had to mark it wrong. Why did I mark it wrong? That's right, because it says find the measure of each side as well. Okay, you've got to make sure that you, because I remember a lot of times on the quiz, I went up here in red and I either like circled it or I put a line under it or something like that. Okay, to show you that that's what you missed on it. A lot of you guys did the work right, but then you didn't find the measure of each side. So how do I find the measure of each side? Plug it in, exactly right. Excuse me. So x is 7. So 7 plus 5 is 12. Now watch, if you wanted to, you could plug it into the other ones, but what's true about all three of these sides? They're all the same. So do I even have to do any more math with this? No. What's this side going to be without doing any math at all? It's got to be 12 because it's equilateral. What's this have to be without doing any math at all? It has to be 12. If you don't believe me, you could plug it in and see if it is. All right? But it saves you a little time, though, doing that, doesn't it? Not plugging them in. That's what I mean. Okay? So do you believe me? 2 times x, 2 times 7 is 14 minus 2. Yep, that's 12, isn't it? What about this one? 3 times x, 3 times 7 is 21, minus 9 is 12. So, yeah, it works out perfect. Does that make sense? A lot of people miss this on the quiz, so you'll probably see something like this on the test, on the midterm and on the regular Chapter 4 test. So let's make sure we know how to do that. They give you another one, number 5. Well, it's number 5 on this, but I think I might have given you another one on the quiz as well. But I'll let you work on that one. I've given you an idea what this is supposed to look like, so we'll just stop there. All right, let's do another type of problem. All right, let's take a look at this one. Yeah, I started it. I'm trying to solve for angle 1, angle 2, and angle 3. Now, we don't know anything about being parallel or anything like that, all right? So it doesn't say that these are parallel, nothing like that, but we do have angles in a triangle. Here's a hint. We talked about how many degrees. What are the sum of all the angles in a triangle? 180 degrees. Okay, that's really the key to this. The key to this is that. But there's another theorem we learned. You remember that exterior angle theorem? And we said it's equal to the sum of the remote interior angles. Do you remember that at all? We're going to use that right here to find angle 1. Well, let's just stick with angle 1 right here. Let's just do angle 1 because oh, I see what you're saying. You're going 3 and 35. You're absolutely right, but this is not 3 degrees though. This is an unknown angle. So you're right. Angle 1 would equal angle 3 plus angle 35. The problem is we don't know angle 3. But we do know two other 58 and 39. That's right. Okay, so this is an exterior angle to this triangle as well, isn't it? So these are the remote interior angles, so all I have to do is just add those two numbers up. The math is very easy here, isn't it? It's just knowing what to do. It's knowing to add those up. That's the key to this. All right, so angle 1 is equal to 58 plus 39. And that's a 17, that's an 8, that's a 9, that's 97. So angle 1 is 97 degrees. Okay? Absolutely right. Look at angle 2 right here. Look at 1 and 2. What do they form? Straight line, don't they? Straight angle. And that's 180 degrees, isn't it? So, Javi, what do we do? You got it. 180 minus that angle right there, which is 97. So let's figure out what that is. That's a 7, that's a 3, and that's a, what, 8? Did I do that right? So that's 83 degrees. Everybody good so far? All right. Now, we could find angle 3 now. And we could do it a couple different ways, I guess. But you could just go... Watch, remember, Sean said this earlier. He said angle 1 is equal to this angle plus this angle. Well, now we know angle 1, right? We didn't before, but now we know angle 1. And we know this one. Yeah, so I think that'd probably be the easiest way to get angle 3. So angle 3 would, right, because these two add up to be 97, don't they? So if I take 35 away from 97, I'm going to get angle 3. That's probably the quickest way to do it. So 97 minus 35, that's a 2, that's a 6, and so that's 62 degrees. And there you go. It's kind of like puzzle pieces, right? You ever do a puzzle? Do people even do puzzles anymore? Do you do puzzles? I don't. I haven't done puzzles. I mean, I used to, long time ago. My grandparents were big into puzzles. Anybody's grandparents do puzzles? It seems like people's grandparents. He can't do puzzles. I remember my grandparents would sit around and they have like, I don't know how many pieces, but it seemed like 1,000 pieces, right? And we'd all, yeah. Oh, I don't have the patience for that. But listen, my point is this. Everybody listen. My point is this about a puzzle. It's really hard to get started. But once you get started and once you start seeing the thing coming together, then you kind of see what you're trying to do, don't you? And then it starts getting easier and easier and it gets better and better. And it starts rolling at the end, right? When you get the end, you start plugging them all in. You're like, oh, yeah, now I know how to do it. This is kind of like one of those puzzles. At first, it might be hard to see where to get started and where to go. But after you find one, then the next thing's a little bit easier. The next thing's a little bit easier. And so I kind of think of this as like a little puzzle. And I don't know if that makes it easier or not, but that's kind of how I think about it. All right, let's do, okay, we'll do this one. Let me draw the picture. Okay, here's our picture. And there's something very important about this that they got to tell you, because you wouldn't know just by looking at it. I mean, you might be able to guess, but you don't know for sure. So here's what they tell you. They tell you polygon, even though it's a four-sided figure, you could call it quadrilateral, I guess, but they call it polygon ABCD is equal to polygon PQRS. PQRS. And that's really important. Don't just blow that thing off. Don't just say, that's just there because they like to write the name of it. That's very, very important to you. Okay, that really helps you out, figure out some of this stuff. Let's use orange. So what does that mean about these angles? What does that tell you about angle A and this other polygon? Equal to Q. How about P? That's right. Okay, so P is first, Q is second. So A and P are equal to each other, aren't they? Now, I could have looked down here and I could have made a guess, and I could have looked at this and said, yeah, it maybe looks like they're equal to each other, right? Because that's obtuse, but how do I know that wasn't equal to this, right? It kind of look close to the same angle, don't they? All right, so in order to be 100% sure, we look up here, we call this a congruent statement. Do you remember that? So this congruent statement right here says that A and P are equal to each other. So check it out. So I know that angle A and angle P are equal to each other. Guess what I can do now? I can set them equal, and then I can solve for X. All right, so let's do that. That wasn't hard to figure out, was it? You didn't even have to look at the picture and know how it was flipped or twisted or anything like that. All you had to do is look up here, and it tells you exactly which angles are equal to each other and which sides are equal to each other. There's no guesswork involved in this. All right, so let's do the math here. Subtract a 4 from both sides. 2x equals, what's that, 96. Divide by 2, and that's 48. Use your calculator if you can't do that in your head. That's fine. All right, so x is 48. So that's half of our answer, because I didn't even tell you what we're trying to do. We're trying to solve for x and y. Solve for x and y. All right, so we found x. We're halfway home. Now I've got to find what y is equal to. Well, where do we see a y? Right here. Let's do this in a different color, blue. So we're trying to find that. So we got to figure out, what is it equal to? Is it equal to 12 or is it equal to 10? Well, let's think about this. Let's look up here. What side is this side right here? It's D what? DC. This one right here. So you come over here and you look to see which one is the same thing as CD. Which one? It's RS, isn't it? So which one is this equal to? Is it equal to 10 or 12? It's equal to 12. All right, and that's That's where it gets a little tricky, because if they give you a couple options right here, you're not really sure which one exactly is it equal to. So you got to look up here to the congruent statement, and it tells you right there which ones are equal. So now we can set them equal to each other. So 3y minus 3 equals 12. Add a 3 to both sides. You must be getting good at this algebra by now, aren't you? Because you've done it over and over and over again. It's 15 divided by 3, and y is 5. There you go. There's your answers right there. Now, they could ask you this. Now, on this problem, they just said solve for x and y. But what else do you think they could have asked you just to make it just a slight bit tougher? Yeah, they might ask you to actually find that angle. Well, actually, if they ask you to find this angle, it'd be pretty easy, wouldn't it? So they wouldn't ask you that, because you could just look at it and write down an answer. It'd be way too easy. Because that's 100, isn't it? I don't have to go through and solve for x and plug it back in. I know that that's 100. What's this equal to? It's 12, right? I don't have to solve for y and plug it back in. I can just look at this and say, oh yeah, they're 12 because of the congruent statement. All right. We okay with that? All right. Kind of looks like Broncos colors right there, doesn't it? Orange and blue. Was anybody pulling for Tim Tebow in the playoffs? Were you pulling for Tebow? I was too. But I tell you what, I love Tim Tebow. I mean, I think he's an awesome person, and he's a great athlete, and he's a great competitor, but I wouldn't want him as my quarterback. Just because he can't throw the ball, man. If he could learn all season, man. Because people were training him, right, to keep the ball up here like this. But, yeah. I hope they do it this all season. But he keeps putting the ball down here. He puts the ball way down here. You can't do that stuff. I mean, David's got way better technique than what Tebow has. But Tebow's tough. I like him a lot. What's that? Yeah. Are you, oh, that's right. You're a Maryland guy, so you're pulling for Ravens, aren't you? I'm pulling for Ravens, too. I hope they win. Packers choked. Oh, well. All right, what do we want to do now? Let's do this one. I don't know if I'll put the proof stuff on there. I think I might save that for your regular test. Okay. Let's do this type right here. Yeah. Why do you... Oh, you like that one better? Oh, it's easy? I could put the proof ones on there. I mean, they're not that hard. I'm not asking you to do too much. Why don't we do that? Let's do one of those proofs, and I'll show you how we do a proof. Sean talked me into it. No, I probably would have done it anyway. Let's do one of the proofs, and I'll just show you what I expect you to do. No? Watch how easy this is. You're going to see this, and you're going to say, what was I worried about? This is way easy. Put all the proofs on there that you want. That's probably what you're going to say. You don't think so? They take time? Nah, watch how quick this is. Because you don't have to write all the stuff. I mean, you don't have to, you know, write all the given and the prove and all that stuff on the test. Say what? I'll put them both on there. You don't like the conversions? Really? Oh, I thought we covered that pretty good. It's a lot of work. The conversion stuff? Like the centimeters and inches and all that stuff? Well, I put all the stuff on there for you. I put all the conversions on there. I did all hard work for you. That doesn't help? Yeah, that big chart, that didn't help? Oh, yeah. I mean, just think if I didn't put that thing on there. Right? So, you know, you got to be, you need to be thankful, right? All right, so let's do this. Now, on the test, I won't make you write the given and the prove stuff, but I do want you to draw the picture and mark up the picture and tell me why the triangles are congruent. Everybody hear me on that? So I do want you to draw the picture, just like I'm doing right here, and I do want you to label the picture and mark it all up. So we've got R, V, T, and S. All right, that's everything they give you. So watch how easy this is. We'll do the stuff in color. All right, so here's all the stuff you need to mark, and I'll do this in red. Everybody watching? It says RS equals TS. How hard is that? Bang, bang. That's easy, isn't it? Everybody likes doing that, don't they? What about this one? V is the midpoint of RT. I need everybody paying attention up here. So watch this. V is the midpoint of RT. So V right here, that's the midpoint of RT. What does that mean if that's the midpoint? What does it do? makes those two sides equal to each other. So we put these two equal to each other. And that's all they tell you in the given, isn't it? And I want to prove these two triangles are congruent. So what else can I tell just by looking at the picture? VS equals VS. That's right. What's the reason for that? Reflexive. Well, the reason that VS equals VS is reflexive property, right? Now, look at it. Now, do I have enough information to say the triangles are congruent? Absolutely. And why are these triangles congruent? Side, side, side. No angles. I don't know anything about any angles. No, it divides the two sides, indeed. Okay? It divides the two sides, okay? So this side equals this side. So we didn't say anything about the angles, did we? Please. I was very polite before. Thank you. All right, so it's side, side, side. That's all you have to do. See everything in red? Well, actually, to tell you the truth, let's put everything in red. There you go. All the stuff in red right there is what you need to write on the test. That's it. That doesn't take too long, does it? The longest part about this is just drawing the picture. Okay, and that's not a hard picture to draw. Draw the picture, mark it up, label it, and tell why the triangles are congruent. That's all you got to do. So I think we're okay putting a couple proofs on there, don't you? Yeah, I think so. Now, if you're in the honors class, you had to do quite a bit more than this. All right, but I'm not making you do that. I'm making it a lot easier for you. So be very grateful to me for doing that. All right? You're welcome. It's terrible when you have to fish for a, a thank you, but that's okay. All right, let's do... Yeah, we got some time, don't we? Let's do this one. Let's pause it for... Okay, I didn't draw this to scale very well, and just because we're running a little short on time now, I'm not going to fix it. But this is a good example. You guys are going to be taking the SAT in a year or two. If you haven't already done it, I don't know. But on the SAT, it's been a long time since I've seen the SAT, but I remember there were being problems where it said, they give you a picture and they say note or something like that. They say figure is not necessarily drawn to scale, which means just because these two sides look like they're equal to each other doesn't necessarily mean they are equal to each other. Does that make sense? I didn't do that on purpose here, but it just kind of works out that way. Look, they put these two. Now, this definitely looks longer than this one, doesn't it? But we just have to go by the information given, all right? So it's not really drawn to scale just because I didn't draw very well. That's the only reason. All right, but this is what's given right here. And this is also given to be 92 degrees. And we have to find a whole bunch of missing stuff. And let's do that in yellow. So instead of writing down, it says CAD. So that would be this. We'll call that angle 1. Angle ACD. We'll call that angle 2. ACB. We'll call that angle 3. And then ABC. This one right here, we'll call that angle 4. That makes it a little easier for you to name the angles. All right, so we got to find all these missing angles. We kind of did something like this earlier today, didn't we? All right, but this is a little bit more complicated. Not much, but just a little bit. All right, let's see what we got. Let's look at 1 and 2 right here. Well, we had a theorem that said if these two sides are equal, what's true about the opposite angles? Lonnie, this is the third time now. Okay, I really want you to not talk and pay attention, please. I appreciate it. All right, look at this. I've got these two sides equal to each other. What does it mean for these two opposite angles? They're equal to each other. Do you remember that? That the angles opposite equal sides are equal to each other. So it was a theorem that we talked about, and that's really going to help you out finding the measure of these two angles right here. This is 92 degrees. Remember, what do I do to find the measure of these angles? Okay, we'll go 180 minus 92. So let's do that. That's a 7, that's a 10, that's an 8, and that's an 8. So that's 88 degrees. Does that mean angle 1 is 88 degrees and angle 2 is 88 degrees? No, it means these two add up to be 88, right? So if they're both exactly the same, you're exactly right. You divide by 2. So if I divide it by 2, I get 44. So this angle right here is 44 degrees, and this angle down here is also 44 degrees. So that was pretty easy. We basically got two answers in one shot, didn't we? All right. Exactly right. See how easy it is? The puzzle's coming together now already, isn't it? Not a very long puzzle, just a 5-piece puzzle, okay, or 4-piece puzzle. All right, so angle 3 right here. It's right next to 2, right? That makes 180 degrees, and so we've talked about this before, so it's 180 minus 44. and that's a 7, that's a 6, that's a 3, that's a 1. So that's 136 degrees. Everybody good so far? All right, now we got to find angle 4. Now, look at this triangle that angle 4 is a part of. I've got a side right here, right, and a side right here that are equal to each other. Is that the best way to do this? Probably. So this angle right here equals this angle up here, doesn't it? So if this is 136, it's basically the same thing we did earlier, isn't it, with the 92? So if this is 136, I do what? 180 minus 136, and that's 44. Divide that by 2, and that is 22. All right.
Will the following students please come to the guidance office?